Okay, let's go to the architecture of Matplotlib. Okay, I'll be teaching you this with the help of a website. Where is that? ATOS. Sorry. Yes. See this now. So Matplotlib was created by John Hunter. Okay, and let's understand how Matplotlib works. Okay. Now Matplotlib architecture is divided into three layers: the backend layer, the artist layer, and the scripting layer. Backend layer, artist layer, and scripting layer. Okay. Now let's understand what all these three are. This is the top level Matplotlib object that contains and manages all of the elements in a graphic is called the figure. Okay. So the top level Matplotlib object that contains and manages all of the elements is called the figure. One of the core architectural tasks Matplotlib must solve is implementing a framework for representing and manipulating the figure that is segregated from the act of rendering the figure to a user interface or hard copy. This enables us to build increasingly sophisticated features and logic into the figure. So figure is the basic layer of your Matplotlib architecture. You can call it as the backend layer also. Okay. So it's like this. If I explain you in simple language, let me use the pen tab quickly. So how do we create a plot? Okay. So first of all, what you have to do, you have to create a, let's say, some area where you want to plot, right? This I can call as figure. Now, either so you want to display the figure on your editor or you want to save it as a hard copy image JPG file. So for that we have a backend which enables us to do this. Now after creating this figure, we have to create an axis, right, on which we do the plotting. And within this axis we create a plot. Let's say I have to create a pie chart. So I have a figure, then I have an axis, and then I have the plot. Okay. So and we usually interact with these two layers. Now let's see how to do this. Okay. So I was reading this. This enables us to build increasingly sophisticated features and logic into the figures, while keeping the backends or output devices relatively simple. Matplotlib encapsulates not just the drawing interfaces to allow rendering to multiple devices, but also the basic event handling and windowing of most popular user interface toolkits. Because of this, user can create fairly rich interactive graphs and toolkits incorporating mouse and keyboard input that can be plugged without modification into the six user interface toolkits we support. अब यहाँ से समझते हैं. The architecture to accomplish this is logically separated into three layers, which can be used as a stack. Stack means one is like three layers, one after the other. Each layer that sits above another layer knows how to talk to the layer below it. But the lower layer is not aware about the layers above it. ये लाइन समझना. Each layer that sits above another layer knows how to talk to the layer below it, but the lower layer is not aware of the layers above it. The three layers from the bottom to top are backend, artist, and scripting. Now let's start with the backend layer. At the bottom of the stack is the backend layer. which provides concrete implementation of the abstract interface classes. So here we have a class called figure canvas, which encapsulates the concept of a surface to draw onto, say for example the paper. Then we have a class called renderer that does the drawing, example like the paintbrush. And then we have a class called event that handles user inputs, for example keyboards and mouse events. Now it says for a user interface toolkit such as Qt, the figure canvas has a concrete implementation which knows how to insert itself into the native Qt window. So Qt is like a GUI for Python, to create GUIs for Python. Okay. So now figure canvas will be like, so in the Qt we can draw this, our fig plots. So it will insert itself into the native Qt window and then transfer the Matplotlib renderer commands onto the canvas qtgui.qpainter. Now this class will do the drawing part and translate native Qt events in the Matplot event framework, which signals the callback dispatcher to generate the events so upstream listeners can handle them. Okay. The abstract base classes reside in Matplotlib backend bases, and all of the derived classes live in the dedicated modules like backends.backend underscore qt4ag. ये सब समझने की इतनी जरूरत नहीं है, बता दूंगा आपको क्या इंपॉर्टेंट है इसमें. For a pure image backend dedicated to producing hard copy output like PDF, PNG, SVG, or PS, the figure canvas implementation might simply set up a file-like object into which the default headers, fonts, microfunctions are defined, as well as the individual objects like line, text, rectangle, etc. that the renderer creates. So canvas is like a area on which we can plot. Now the job of the renderer is to provide a low level drawing interface for putting ink to the canvas. So low level interfaces are those in which it's not very easy to code. As mentioned above, the original Matplotlib application was Matplotlib was actually created as a ECG viewer in the field of healthcare. Okay, into a GTK plus application. This is again a toolkit for Python, and much of the original design was inspired by this API available at that time. Now this renderer has different class objects like draw point, draw line, draw rectangle, draw image, draw polygon, and draw glyphs. So actually you can create plot using this only, but this is a low level API, so it might be not very easy to code on this. Okay. Now let's do some slide coding to understand this even better. Where is that gone? So create a new file called matplotlib and start coding.
Himanshu,
Yes.
sorry to interrupt. Could you just explain that figure which you have drawn in the notes once again? I
Sure.
joined a little late.
So while plotting, there are three layers in Matplotlib. One is called the backend. There's the artist layer
Matplotlib is a
library
library. Okay.
in Python that is used for doing all the plotting.
Okay.
Okay. So we have this backend layer, we have this artist layer, and we have this scripting layer. Okay, so backend layer is responsible for creating the graphs or creating a hard copy images. Then Axis will define your grid and all, where the area where I have to plot. And the scripting layer will be used for passing on the data to plotting.
Okay.
So our major interaction will be with scripting layer only. Well, some interaction will be with the artist layer also, but very less interaction with the last layer.
Background.
Exactly. Okay. Now let's so before so we now as of now we have not imported it. It says you can show matplotlib figures directly into the notebook by using percentage matplotlib notebook and percentage matplotlib inline magic commands. Notebook is more interactive, inline is not very interactive. Inline we have done earlier also. Right. Now execute this. Okay. So once I do some plotting, it will create an interactive plot. I will show you that. Now I'm importing Matplotlib as MPL and I'm looking at the backend that I have here. Okay. So it's using NBAG. That's the name of the backend that we'll be using here. There are a lot of other
So a
backends.
note,
Sorry.
you're passing what is notebook here?
Come again.
नोटबुक क्या है यहाँ पे आपने मैटप्लॉटलिब नोटबुक लिखे हैं नोटबुक क्या है ये
Notebook
या दिस वन
if is for creating interactive it will create an interactive environment here in Jupyter Notebook जब हम plot बनाएंगे.
ओके
Okay, we'll see this. ऐसा करके आएगा आपका.
ओके इट्स लाइक दिस
Hmm.
इन जुपिटर नोटबुक गॉट इट
Yes. Yes, Pranali.
What is the difference between that percentage matplotlib अभी तक बता
This one and this one.
matplotlib line
Come again, Pranali. फिर repeat. Please repeat.
percentage matplotlib inline हम कर रहे थे अभी तक.
Mm-hmm. Right. So
Okay,
notebook
now,
is yes. So now we are doing notebook. That's what you're asking.
and then what is the difference between this and import
Okay.
matplotlib?
So this any command which starts with a percentage is called some magic command in Python in Jupyter.
हाँ.
These are other some set of inbuilt commands that we use for some quick procedures. So Matplotlib notebook will create some. Now see this. If I do this plotting, देखना यहाँ पे. Sorry. See this. Now I have an interactive environment where I can give input through mouse also.
Okay.
See this. ये आपको दिख रहा है राइट सब कोऑर्डिनेट्स दिख रहे हैं यहाँ पे माउस मूव कर रहा हूँ तो ओके ये चीज अगर मैं इनलाइन करता तो ये सब इंटरेक्टिव नहीं आता है वो
नहीं आता है. ओके. सो अब हम इनलाइन करके भी प्लॉट कर सकते थे. तो यहाँ पे हमने फिर एक्सप्लिसिटली व्हाई वी हैव इंपोर्टेड दैट पैकेज
नहीं तो
मैटप्लॉटलिब.
इससे आपसे प्लॉट कर सकते बट आप फंक्शंस कैसे लिखोगे उस पे दिस इज ओनली टू रेंडर इट ये आपका बैकएंड है इज ओनली फॉर रेंडरिंग द इमेज बट हाउ विल यू क्रिएट स्क्रिप्ट्स ऑन इट उसके लिए आपको एमबीए चाहिए पीएलटी
स्क्रिप्ट लेयर के लिए.
ये भी आपको समझाता हूँ मैं इतना कर लो अभी ओके एमपीएल डॉट करके देख लो क्या क्या फंक्शंस हैं उसमें ये कंप्लीट क्यों नहीं करा बहुत स्लो हो गया है ये सी दिस
Hello.
yes yes
Yes, sir. I'm getting error. Percentage
which?
matplotlib.
Notebook?
On magic plotly. Yeah.
कोड पिंग करो नोटबुक की स्पेलिंग गलत है
Oh, sorry.
ओके
Okay.
now anything I do with this MPL is on the backend layer it's not printing it yes so we have these many backends available Okay, PDF for creating PDF graphs directly for Mac OS, for PostScript files. So this is the default NBAGG which we use. Okay, there's
One
so
question,
many.
Himanshu. हम लोग any kind of file we can generate like a PDF or a JPEG. Can we export this file to some our local machine or different
Yes, yes,
environment?
of course, yes. Mm.
And one thing, if you don't put a Matplotlib notebook or inline and try to import a Matplotlib and try to give this a get backend, whether it will generate the graph or not?
It will not show you the graph. See, if you
Okay.
don't run
But
this, you won't see any graph on the Jupyter notebook.
so where it will display?
It won't display
Okay.
anywhere.
Okay.
Okay. Now let's come back. So this is the backend that we are using. Now let's come back to the theory again. Okay. So now the Matplotlib inline or the Matplotlib notebook is the renderer here, which is allowing us to render that image. Okay. Now what we are going to do now is see this. Then in the Matplot we have also some event class which framework maps underlying UI events like key press event or mouse motion events to the Matplot classes key event or mouse event. Users can connect to these events to call by functions and interact with their figure and data. So for example, you have to create a map or some graph on which from which you have to take user input also. Means if a user clicks on it, you want to execute some function. So that can be done using this key event or mouse events. But we have high level APIs for this also, so we don't interact with this directly. Okay. So let me run this code just for showing you this. NumPy plt created a function. See this. So what I'm doing here, I'll just explain you this quickly. So now this is importing this. I have created a function called onPress event. Now if event.inAccess is none, return. For line in event.inAccess.lines, if the event key is t, visible is equal to line.getVisible. Okay, the default is not visible. Now this is the function. Now look at this fig comma x. So now I'm creating a subplot. Okay, and this is again the backend canvas.mpl connect key press event on press. Now just press T over here. See this. It is toggling. T से toggle हो रहा है वो. Okay. So for such kind of interactions we can use Matplotlib also. So what we will not be doing this, we will be doing mostly for data science only. Okay. Yeah. Now this code is pretty much difficult to write. So we can write this code also with a high level API also, which we'll see later on. The abstraction of the underlying UI toolkit's event framework allows both Matplotlib developers and end users to write UI event handling code in a write once, run everywhere fashion. For example, the interactive panning and zooming of Matplotlib figures that works across all user interface toolkits implemented in the Matplotlib event framework. So now in this case, you can also उसको कोड हटा दिया क्या मैंने? Okay, leave it now. छोड़ दो उसको, जरूरत नहीं है. Yes. So this was all about the backend layer. Backend layer is the primary layer of your Matplotlib. Ideally, you can create everything from Matplotlib layer only, but we usually don't do that because it's difficult to code on that. Then we have an artist layer. Okay, now this is very interesting. The artist hierarchy is the middle layer of the Matplotlib stack, and is the place where much of the heavy lifting happens. Containing the energy that the figure canvas from the backend is the paper. The artist is the object that knows how to take the renderer or the paintbrush and put ink on the canvas. So canvas was a paper, renderer was like a paintbrush, and now I have to plot something. That artist will tell you that. Okay. Everything you see in a Matplot figure is an artist instance. Artist instance means it's an instance of that object only. Like the title, the lines, the tick labels, the images, and so on. All correspond to individual artist instances. Okay. The base class is matplotlib.artist.artist, which has all these methods, which contain attributes that every artist shares. The transformation which translates the artist coordinate system to the canvas coordinate system discussed in the visibility, the clip box which defines the region the artist can paint into, the label and the interface to handle user interaction such as speaking. That is detecting when a mouse click happens over the artist. Now see this. So now suppose this is a figure. Okay. So we have this. We have so many things. We have an x-axis, y-axis. We have this title. We have x labels, y labels. We have this curve. Okay. Now see this. इसको ध्यान से देखना. At the back we have this figure 1. This one, which is the paper on which we want to plot. Okay. Then we have this axis which is connected to this figure 2, which is this square grid 2. Okay. Now on this axis we have so many things. We have this plot, we have x label, y labels and all. See this. On this axis we have a line 2D line which is by number 3. So this is again an artist. Okay. Now we have text 4. What is 4 here? That is my title. Then we have a y-axis which is 5. Then we have x-axis which is 6. These are not the labels. This is axis, y-axis and x-axis. Now each of them is artist in themselves, so they will have sub-elements also. Now y-axis will have two things, y label and y ticks. Y label means the label that is voltage here, and y ticks means these values 0.5, 1, 0 and so on. Similarly in x-axis I have x label and x ticks, and x ticks ke andar I have this ticks and y ticks also have this ticks. So this is a list which has these numbers. Now if you understand this hierarchy, you can easily understand how to access each and every element and change it or create it. Okay. So if I want to change the y label, I have to reach here. So means I have to, from figure I have to go to axis, then I have to go to y axis, and then I have to go with y label. So this graph is very critical. We will come back to this again while we'll start the plotting. The point you have to understand is each and every thing in the graph is an artist instance. Getting this? Pranali, Akshay, Samir,
Yes.
Yeah,
Jitendra.
Himanshu.
Okay. Now it says the coupling between the artist hierarchy and the backend happens in the draw method. For example, in the mockup class below, where we create some artist with subclasses artist. The essential method that some artist must implement is draw, which is passed a renderer from the backend. Okay. The artist doesn't know what kind of backend the renderer is going to draw onto, like PDF, SVG, etc. But it does knows the render API and will call the appropriate method draw text or draw path. Since the renderer has a point to its canvas and knows how to paint onto it, the draw method transforms the abstract representation of the artist to colors and pixel buffer path in an SVG file or any concrete representation. So when I have to create anything, artist will call those methods of the renderer API like draw text or draw path. So you have to create some text. Say for example, I have to create Y labels. So artist will call draw text. Now see this. I'm creating a class here called SomeArtist, which takes the argument artist. An example artist that implements the draw method. Function draw, self, and render. This so so now it will be asking for the render here. Call the appropriate render methods to paint self onto canvas. Self means the artist. If not, self.getVisible return. Create some objects and use renderer to draw self here. So now within this render we have draw path and which we have graphics context, path and transform. Okay. So this is of course very abstract, which we don't usually don't do. So this is how an artist. This is the backend of Matplotlib, you can say. The artist is getting connected to the renderer. Okay. Now there are two types of artists in the hierarchy. One is primitive artists, represent the kind of objects you see in a plot. Primitive, like line, 2D, rectangle, circle, and text. So primitive cannot be further divided. Composite artists are collection of artists such as axis, tick, axis, and figure. So now these axis, tick, axis will have sub-elements also. Each composite artist may contain other composite artists as well as primitive artists. So जैसे यहाँ पे if you see this is a composite artist which has two elements, X label and X ticks. X label is primitive, X ticks is again composite, so which has a further artist. Okay. For example, the figure contains, yes, it says for example the figure contains one or more components, composite axis, and the background of the figure is a primitive rectangle. No. Okay. Now let's get into this. It says the most important composite artist is the axis, which is where most of the Matplotlib API plotting methods are defined. So within this axis object, we have most of the plotting methods. Not only the axis contain most of the graphical elements that make up the background of the plot, like the text, the axis lines, the grid, the patch of the color, which is the plot background. It contains numerous helper methods also that creates primitive artists and add them to the axis instance. For example, table 11.1 shows a small sampling of axis methods that create a plot objects and store them in the axis instance. See this. Now I have axis.im_show. It creates one or more images. Axis.hist will create many histograms. And axis.plot will be one or more matplot, it will create 2D lines. Okay. Below is a simple Python script illustrating the architecture above. It defines the backend connects a figure to it. Uses the array library NumPy to create 10,000 normally distributed random numbers and plot a histogram of this. Okay. Now see this, what we are doing here. Import the figure canvas from the backend of your choice and attach the figure artist to it. From matplotlib.backends. I am using backend underscore agg, importing this figure canvas agg as figure canvas. So now I have, that's the figure. That's the backend that I have created or imported. From matplot.figure import figure, and then this is the instance of this figure. So now what I'm doing is, in this figure canvas I will pass this figure and my canvas is ready. So now on this canvas I'm going to do the plotting. Don't worry about the code, just try to understand it. I imported NumPy and I created 10,000 normally distributed random numbers. Now use a figure method to create an axis artist. The axis artist is added automatically to the figure container fig.axis. See this now. Now in this figure, that is a figure, I have the function called add underscore subplot, which takes three values like this, 1, 1, 1. It means create a grid with one row and one column and use the first cell in that grid for the location. Suppose I have to create two plots, I will put this at 2, 1, 1. Means two rows, one column, like this. Suppose you have to create two plots like this, right? So I have two rows, right? 1 and 2, and this is one column. So if I have to do something here, I will do 2, 1, 1. If I have to do something here, I will do 2, 1, 2. Comma is also not required, 2, 1, 2. So it will create two subplots. Similarly, if I have like this, I have to create four plots like this. So now I have to create something here, I will pass 2, 2, 1. Okay. This is, I believe, 2, 2, 2. This is 2, 2, 3, and this is 2, 2, 4. We'll see this while doing the plotting. Okay. Now I have created an axis on which I want to create the plot. So now I am in the artist layer where I have created this axis. Now to plot the histogram, I can simply call ax.histogram x, 100. Okay. 100 means 100 bins I want to use. Now to decorate the figure, I want to create a title. So I have, within ax, I also have set underscore title. And eventually I have to save the figure. So fig.save figure, a PNG file will be saved. Okay. So from this, the things you have to understand is this, from this ax, the instance I am creating from this fig. Okay. Now comes the most important part of it, the scripting layer, that is pyplot. Now the script using the API above works very well, this one, especially for programmers, and is usually the appropriate programming paradigm when writing a web application server, a UI application, or perhaps a script to be shared with other developers. Now he says writing code on the artist layer is good for developers or people who want to create some applications on it, but it's not good for users or data scientists. So for everyday purposes, particularly for interactive exploratory work by bench scientists who are not professional programmers, it is a bit synthetically heavy and most special purpose languages for data analysis and visualization provide a lighter scripting interface to simplify common tasks. And that's why we have this pipeplot. Okay. Now this is the scripting layer. This sits on the artist layer, artist sits on the backend. Now pipeplot is not the only layer that's provided by Matplotlib. There is some paid packages also. Like there is one called Boca, one called Seaborn, one called PyLab. There's one more very famous, Plotly. So these in the third-party packages are all on the scripting layer. So what they do, they simply connect to the artist layer, and so the artist layer and artist connects to the backend. So they have their own API for this scripting layer only. Now doing the same thing that we did here is pretty much simple using the pipeplot. So I imported Matplotlib pipeplot as PLT, NumPy again. I created the NumPy array and simply plt.hist x, 100. plt.title, plt.savefigure, plt.show, and you get the graph. So very simple lines of code, right? So in PLT, have all these methods implemented already. But sometimes we have to play with the artist layer also. Now let's quickly understand this before we start coding. It says pipeplot is a stateful interface that handles much of the boilerplate for creating figures and axes and connecting them to the backend of your choice, and maintains module level internal data structures representing the current figures and axes to which to direct the plotting commands. Let's dissect the important lines in the script to see how this internal state is managed. So first, this we know. When the pipeplot module is loaded, it parses a local configuration file in which the user states, among many other things, their preference for a default backend. This might be a user interface backend like Qt in which case the script above will import the GUI framework and launch a Qt window with the plot embedded. Or it might be a pure image backend like AGG. Okay. So if I use the backend as AGG, I won't get any display. I will get a hard copy output like a JPG file. Now look at this plt.hist. Now this is critical. It says this is the first plotting command in the script pipeplot. Pipeplot will check its internal data structure to see if there is a current figure instance, means whether there is current figure already existing or not. If so, it will extract the current axis from that figure and direct plot into the axis.hist API call. So if there is already figure existing, it will simply use those figure to do the plotting. In this case, there is none, so there is no plot as of now. So it will create a figure first of all. Means this line, the way we did here. Yeah, fig is equal to figure. Okay. So this is all. So we are not calling it explicitly now. Simply plt.hist will call it at the backend if there is no figure directly existing. Okay. Now plt.title will simply call. So now I have to create the title. As above, pipeplot will look into see if there is a current figure and axis. Finding that there is already, it will not create new instances, but will direct the call to the existing access instance method access.setTitle. Now this can have different methods. Here we have plt.title to do the write the title. Here we have set_title. So if you are using the artist layer, so you have to use this. If you are using the scripting layer, you have to use this. So ये ध्यान रखना थोड़ा. Now plt.show, this will force the figure to render, and if the user has indicated a default GUI backend in their configuration file, it will start the GUI main loop and raise any figures created to the screen. So plt.show will show you the graph. Okay. I think that would be enough for the theory. Now let's start doing it quickly. I hope you got the idea of like what Matplotlib is doing at the backend. Yes, Akshay, Samir,
Yeah, Himanshu, kind of.
Jitendra.
Yes.
Okay.
Hmm.
Now,
So mostly we'll deal with the artist layer and this PyPlot
mostly
scripting layer.
scripting there only, yes. So in industry, some people, some companies might be using some paid packages also like Plotly and all. In that case, you will be calling that here.
Some of the things I also this Seaborn, which is also on a part of the Matplot.
Yes, yes, Cborn is here. So instead of PyPlot, you can go for that also. I think Cborn is also free. ये complete क्यों नहीं कर रहा यार? No, I think it's not. You have to install it. It's not installed as of now. So PyLab is also there. PyLab you can use. है क्या Cborn इधर?
हाँ
किधर है Cborn?
नहीं C1 नहीं PyPlot दिखा मुझे
PyPlot तो है.
PyPlot.
Right. So now we have this PLT and then we have PLT.plot function.
So for C1 color, we need to install and just import as C1, then it will display.
Right.
First we need to install.
Exactly, yes. So you can just simply search Cborn Python. Installing and getting started. So pip install Cborn will do that. Or our case conda install will also work. Okay, and then you can import it and start working. Okay. Now start doing this. Import PLT.
सीबोर भी इंस्टॉल करना है क्या?
नहीं नहीं.
वो क्या है एक्चुअली? व्हाट इज दैट? सीबोर?
Instead of PyPlot, we have the others. We can use some different scripting there.
Yeah, okay.
Okay, so we can have different scripting layers for do the plotting, and they will have their own set of methods and all. ggplot you can also use ggplot also.
Okay.
But ggplot दो R packages, तो यहाँ पे भी काम करेगा.
ggplot बना हुआ है इसके लिए भी. मतलब it's not like a R like thing. It's like the interface will look like GUI. The plots will look like the ggplots. Now see this. If I do plt.plot 3,2, it has created a figure now, right? So this is your figure. That's your axis. So this is my artist here. So I have this 2D artist, then I have my X label and Y X ticks and Y ticks, right? With that one. But it's not showing you this 3,2 point. Why? Because the default line style is dash, means between 2 points it's joined by a dash. Since I have only a single point I am plotting here, that's why it's not showing me anything. If you want to look into that point, do this now. Pass this. Okay, now this is the problem with notebook. See this, now the instance was already created there, right? So it has simply created on this only. It has not created a new figure. But for this is not for inline. Inline will create a new instance. Okay. So now this 3,2 orange point is plotted. So because I have passed this marker over here also. So I want to indicate the marker dot over here. Now,
Sir,
yes.
मेरे इसमें blue आया.
Sorry.
I got blue point.
You got blue point in Azure only.
Yeah.
Strange. Backend is your backend is same, right? NBAGG है ना आपका? ये चेक कर लेना एक बार.
देखते हैं. NPAGG.
नहीं फिर तो सेम आना चाहिए. कलर वाला तो इससे डिसाइड होता है रेंडर से.
ब्लू कलर का पॉइंट आया 3-2 पे ही, लेकिन आया ब्लू कलर. आपका ऑरेंज है.
हेलो.
डिफॉल्ट आई थिंक ऑरेंज ही आता है. यस.
फिर हमारा भी ब्लू कलर में आ रहा है.
ना मेरा ऑरेंज आ रहा है.
नहीं, you can change the color also. I will teach you how to do that. Okay. Pass like this. I think this will do it. Yes. Pranali, pass this B dot, then it will give you a blue dot.
और मेरा तो पहले ही ब्लू आ रहा है.
You pass O dot.
और
O is not allowed. उसका देखना पड़ेगा क्या ऑरेंज का. R is there for red.
मार्कर का क्या बताया आपने?
Sorry.
नहीं, ये why we have passed कोट्स के अंदर डॉट क्यों पास किया था?
Because I want a marker like this. The default marker is a dash between 2 points.
Okay, okay.
So
as we have plot only one time.
yes, it's not showing you anything.
अच्छा.
अगर आपने एक array पास किया होता तो वो डॉटेड लाइन बना, एक डैश लाइन बना देता.
हेलो.
Yes.
हेलो. Yes sir, on passing R we are getting
A red
color.
dot. Yes.
Yeah.
I think if you remove R now and execute, each time it gives different color.
Okay, I think it will be random or something. Yes.
Keep on executing, it gives on different color.
Yes. I think it's randomly selecting the colors. Yes. Okay. Now this was very simple using a plt.plot, right? Now let's do the same thing using the scripting layer. Sorry, without the scripting layer, using the artist layer. So now it will be a bit difficult. So do this from matplotlib.backends.backend underscore agg. So that's the backend I'm going to use, agg. Import figure canvas agg. Do this now. And from matplot.figure import figure. Done.
1 minute. कुछ एरर शो कर रहा है, सिंटैक्स एरर मतलब फॉर सेकंड लाइन.
चेक करो.
फिगर तक एग्जीक्यूट करना है,
ओके बट
फंक्शन भी क्रिएट करना है क्या फिगर तक?
आपने 2 बार फ्रॉम क्यों लिख दिया वहां पे?
या दैट्स फाइन. आई गॉट इट.
So you know this from, right? So means I don't want to import the complete matplotlib.figure. I just want to import one method from all this.
या करेक्ट.
Okay. So for example मुझे numpy से सिर्फ mean import करना है, तो from numpy import mean. So it won't import all the methods of numpy, it will only import mean.
Till what we have to execute?
Sorry.
Till where we have to execute?
No, okay, so done this, now we'll be creating a new figure.
Yeah.
Okay, and then I'm creating a new associate figure with this backend. So this figure canvas is the backend. I'm associating this figure on this. So my canvas is ready. Okay. Now in this figure, I have an element, a method called add underscore subplot 111. So I'm creating an axis now. I'm trying to plot here like this axis. Okay, see this now. So now if I just execute this cell up to here. Okay, anyway, it's not going to plot anything because I'm using this EGG.
Why so? If you use AGG, it won't.
In AGG, it won't do any plotting. It will just save a PNG file. We'll see that. Now do the plotting. So this is the plot created, ax.plot. And now you can save over here. Okay. Now if you look into your library, you'll have this canvas file now. I hope you created a new directory for Matplotlib. कि नहीं किया?
नहीं, उसी में किया.
उसी में कर दिया क्या? इसमें आपको एक PNG आ गया होगा, फिर देखो जिसमें भी किया उसमें PNG फाइल आ गया होगा. Execute this, एक फाइल आ गया होगा. Now you can easily display using the HTML here. There's again a benefit of Jupyter Notebook. I can execute HTML also here. See this. Image source equal to test.png. आपका डॉट आ गया.
So it should create a new plot, right? New figure.
Just create a PNG file. I just simply displayed this image file. Like we do in an HTML page, right? IMG source is this.
Okay.
The IMG tag of HTML will render that image file. So now this cell is an HTML cell because I put this percentage HTML.
Mansoor,
Yes, Jitendra.
hello. Please follow.
Yes.
Can you say?
Done?
Hmm.
Okay. Okay. Now same thing I can also do means now you see this I will be not using this backend I will be using my normal backend only that is NBAGG, right?
NBGG.
Yeah. So now okay, just a second, Jitendra is getting error. आपका कोड ठीक नहीं है जितेंद्र. कैनवास इज इक्वल टू गलत लिखा है वो आपने.
कैनवास
ये देखो
क्या आएगा?
2 बार आ गया वो फिगर कैनवास.
फिगर कैनवास को.
ये देखो. हाँ. Okay. Now
Okay.
let's see how we can do this using a PLT now. So PLT.figure will create a new figure. Okay. And now create this plot. See this now.
So the code. GCA क्या है यहाँ पे? PLT.GCA.
Yes, I will tell you that. पहले समझ में आया? You know what is PLT dot figure? We created this figure, right? Now we created this plot. Now
Hello?
from this, yes.
सर IMG SRC कैसे लिखा था? Scroll up please. IMG. Okay.
पहले ये जरूर लिखना %% HTML.
Okay.
वरना HTML नहीं चलेगा, वरना एरर देगा वो. See this now. जितेंद्र यहाँ पे ध्यान दीजिए एक मिनट. Now from the scripting layer, I want to go to the artist layer. So I have to access the axes, right? So plt.gca will give me GCA means get current access. So now from the scripting layer, I am moving to the artist layer, and that is saved in AX. Now I will have various methods of this AX, which I can use. See this: add artist, add callback, add image, add line, all this. Now within on this axis, I have thing called access, which is used to set access properties. Xmin, Xmax, Ymin, Ymax ऐसे पास होता है as a list. And now if I do this, I get a plot like this, which has see this. Yeah.
Okay.
Minimum 0, maximum 6, minimum 0, maximum 10, X और Y. No, ये चीज जरूरी नहीं हम यहाँ से करते हैं, PLT से भी कर सकते थे. नहीं तो एक्सेस ऐड करने के लिए है. Yes. So the same thing I can do like this also, plt.access. Right? So this time I'm not accessing the access layer, I'm just doing this from the scripting layer only.
Yes.
Okay. So this is easier, PLT easier, but this is a bit limited. This gives you a lot of options. तो थोड़ा सा वो difficult पड़ता है AX पे करना.
सर वो O से क्या हुआ? बड़ा पॉइंट आ गया क्या?
नहीं, O से मार्कर है वो.
ऐसे क्या क्या ऑप्शंस होते हैं?
वो देखने के लिए आपको ये देखना पड़ेगा. PLT की सॉरी नॉट मैटप्लॉटलिब का एक पूरा कहाँ गया वो? I'll show you this. Yes. इसका पूरा डॉक्यूमेंटेशन इस वेबसाइट पे है. Okay. So you can search for plot. So हम ये यूज कर रहे हैं. Okay. Not this one. BO is action using blue circle markers. Okay. R plus will give you R and plus. Then we have this color marker, line style, line width, marker size.
Line width, marker size.
Okay. So these are the parameters that you can pass.
और 6.10 कहाँ पॉइंट हो गया? वो 2,3 पे हो गया ना?
ये?
हाँ? नहीं वो ax.axis 06010.
ये तो आपका एक्सेस बता रहा है ना, मिनिमम ये 0 से 6 और 0 से 10. Hello. We are deciding,
Yeah, got it.
deciding the axis. Point is at 3,
Min-max.
yeah.
Okay. The 3,11 वगैरह डाले तो it doesn't give error, right? It just
It won't show. Is it showing that?
It won't show, but it won't give error.
Yes, it won't give an error. Yes. Yep, done. Now let's create these 3 points. Can you do this yourself?
ये 3 प्लॉट इंस्ट्रक्शंस ऐड करेंगे ना, या कुछ फॉर लूप वगैरह से लिखना है?
नहीं, plt.plot से ही लिख लो.
ओके,
देखो फिगर 1 रहना चाहिए, उसके बाद प्लॉट तो स्क्रिप्टिंग ले रहा है तो उसके ऊपर ही लिख देगा वो. So 1.5 1.50 1220 2.5 2.50.
ओके.
Okay, it will give you like this.
इसमें जो कलर्स आ रहे थे, व्हाट आर द कलर्स मोस्टली? ओनली रेड, ग्रीन, ब्लू और मिक्स ऑफ एवरीथिंग. वो कलर्स आ रहे हैं यहाँ पे.
ये आते हैं ऑरेंज, ग्रीन, ब्लू मोस्टली आता है, रेड आता है.
और
आप चाहे तो पास कर सकते हो यहाँ से. Okay, I think it takes the RGB values in hex code also. So this is ये रेड कर दिया एक. And now you can also set the access also using plt.access.
With Himanshu, without defining access, take 2.4, 2.4
Come again.
maximum. You had not defined the access right till now.
Yeah, so it is default तो लेगी ना कुछ वो.
Oh, good. Okay.
It will create automatically by default. Now I have used this access. So I've done it very easily with plt.access only directly.
सर ये अपने आप कलर क्यों चेंज कर देता है?
पास कर दो, सेम तो नहीं करेगा. तीनों को
बट
रेड कर दो.
ऐसे नहीं, बट ये तो फिर वो आगे तो कितना कठिन हो जाता होगा. ये इतने जैसे प्लॉट है इसलिए ठीक है, हम कर सकते हैं उसको मैनेज.
नहीं वैसे नहीं करेगा. मतलब अगर इसमें आप एक ही में करोगे तो नहीं करेगा.
अभी सब जैसे अभी मुझे अगर कोई लाइन ड्रॉ करने का एल्गोरिदम इम्प्लीमेंट करना है,
हाँ, तो
उसमें
नहीं
तो
है
हर एक फॉर लूप के अंदर एक
नहीं. हाँ तो उसमें नहीं, उसमें plt.plot नहीं बनाओगी ना बार बार.
बनेगा ना सर. मैं एक फॉर लूप के अंदर वो लाइन के सारे पॉइंट्स फ्रॉम स्टार्टिंग पॉइंट टू एंड पॉइंट एक इंक्रीमेंट करते डालती जाऊंगी, तो वो उतनी बार तो प्लॉट फंक्शन में कॉल करेगा ही
नहीं. वैसा ना करके अगर आप सीधा इसमें एक numpy array पास कर दोगी तो सेम कलर का दे देगा आपको.
अच्छा,
है ना, वो देखेंगे अभी आगे हम.
ठीक है.
Or what does that GCA do? Could you just tell once again?
GCA gives you the access to the current access.
Access to the current access. Huh?
Means now this is my scripting layer, PLT, right? Behind of that there is a artist layer.
Yes, sir. Just okay.
On artist layer we have this AX access. So now I want to move from the scripting layer to the artist layer. So I'm telling PLT to get current access. So I get this AX. And now I can do any changes with my access layer. Now I'm working on the artist layer.
Oh. Okay.
So it will have all those methods that we have on the AX.
Okay.
So in the next code I have done the same thing, but this time from the scripting layer only. Okay, but if I have to set the, see this now, if I have to set the title, I have plt dot title here. Let's say first graph. Okay, but the same thing if you have to do using the access layer, you have to do, I'll just comment this out. So that's the graph without I'll do AX is equal to plt dot GCA and then AX dot set title, and then first graph. Same thing, but one is from scripting layer, one is from artist layer. Getting this, Akshay?
Yeah, Himanshu, yeah.
Okay, very good. Now let's move ahead. Now let's do this. axplt.gc and run this. It will show what all things, all the children, what are all the primitive and composite artists that this AX artist has. See this now. This axis has a line 2D. So these are my 3 points. Okay. Then from this matplotlib.spines.spine, this is what 1, 2, 3, 4. एक सेकेंड, 4 चीजें क्या है यहाँ पे? I think this is for your this 4 lines, 4 figures. 1, 2, 3, 4. Yeah, that's for the rectangle. So that's for the rectangle spine.
2 minutes.
Then we have the x-axis, and then we have the y-axis. Samir, please mute. See this. So that's my x and y-axis. That's my text, title text. That's my x label. That's my y label. Now these patches is that's the rectangle. What is this for? Spines. एक रेक्टेंगल आ गया, 3 points, line 2D हो गया, x axis हो गया. Okay. Now it won't show you the. So now we have this title also, and then I don't have any of these titles. This spines look to be for rectangle only, but I have to check that. Okay, let's do one more plot, then we'll check for that also. Okay, so now these elements, there are so many elements that we have here. Now suppose I want to access this title here. So what I will do? X dot get.
Title.
I think title होना चाहिए. Yes. First graph. इसमें आप उसकी पोजीशन चेंज कर सकते हो. नहीं, ये तो फिर हट क्या है. Means I am extracting it, I have to set it again. I can set it from x dot set title. Now let's do some scatter plots quickly. Create a numpy array from 1 to 8, and then y is equal to x. You can do use a range also, no issues. ऐसे नहीं करना तो np dot a range से कर दीजिए. Yes, done. And now plt.figure will create a new figure, otherwise it will plot on the old plot only. If you don't do this plt.figure, and then plt.scatter x comma y, that's it.
हिमांशु एक बार पिंग करोगे क्या एक कोड प्लीज?
Sure.
It's done.
Done?
Yeah.
Okay. Now if I pass here, oops, sorry, dash. Nice, scatter भी नहीं कर रहा वो. Why is not plotting? There is an error. No, this is not allowed here. That's not for. This is only for plot, not here. Okay. Now what I want to do here is I just want to have all those colors as green. The last one should be red. So now I have this x and y arrays ready with me. I have created a list of green colors, and then I appended a red also here. Do this.
Himanshu, यहाँ पे आपने mentioned s is equal to 100 and it's mentioned size of
साइज
100, but
साइज है साइज।
what is it?
Yes.
But कहाँ पे ये
ये
लिखा है
साइज,
size का?
इसका साइज
Okay, okay,
कम कर दो इसको तो दिख जाएगा वो अलग से।
right.
ओके जिप जनरेटर क्यों यूज कर रहे हैं यहाँ पे? Leave this not required. Do this now. Again y is equal to x ही है। Okay, but this time I have three. So I have plt dot figure. I have a scatter plot. Okay, now this is again very good. See this. So I am creating two scatter plots here. So the two initial values are in red color, called by the label tall students, and the last five values are with the name on the blue color with short students. Do this now. Yes, done.
सर मेरे इसमें लेबल नहीं आ रहा है।
ये लेबल
Yeah,
आपके इसमें कैसे रेड वालों को टॉल दिखाता है और शॉर्ट ब्लू के आगे शॉर्ट, वैसा मेरे इसमें नहीं आ रहा है।
ये कह रही हो?
हाँ
ये तो अभी किया नहीं आपने, लेजेंड नीचे किया है वो अभी ये भी नहीं आ रहा होगा,
अच्छा
एक्स और वाई लेवल्स भी नहीं आए होंगे आपके।
नहीं कुछ नहीं आया, तो वही मैं
हाँ,
देख रही थी कि
वो
कहाँ
यहाँ
पे
पे है,
खोल।
वो यहाँ पे है।
ओके ओके।
देखो plt.x लेबल गिव यू द x लेबल, y लेबल, टाइटल, इसको आप आर्टिस्ट लेयर से भी कर सकते थे। ओके, एंड देन द लेजेंड will give you the legend. It says no handles with labels found to put. Why is it so? Okay, I have not executed this, I think. Yes. ये चीज ध्यान रखना, जो यहाँ पे लेबल्स है ना आपके, these will be used for the legends. जो स्कैटर बॉट में अपने प्लस की पास किया, ये नहीं होगा तो फिर एरर देगा वो।
हिमांशु थोड़ा स्क्रॉल डाउन करो।
Now you can change the location also this. ये देखो, इसको यहाँ कर दिया, ये अच्छा नहीं दिख रहा वैसे अब, है ना। और फ्रेम को मैंने ऑफ कर दिया है, इसको ट्रू कर दो, ज़्यादा बेटर है, थोड़ा ठीक दिखेगा। Then see this legend, this Okay. Now look at this. Look at all the children. Get children. So these are your scatter path collections for your scatter plots. This one and this one. वो spine rectangle के लिए ही है. The borders of the rectangle maybe. Now see this. What I am doing here in this line. Now I'm accessing the legend through this plt.gca, and that get children will give me this list, and then -2 will give me this second last one. I am saving it in legend, and then I will print it also. Okay. Now I will have this will have further children also. So legend dot say this. It has two things. One is offset box and one is patches, fancy box patch. Now this also has further children and so on. So this you can see all the complete hierarchy. Or you can write a for loop to do that. It will go up to the bottom. That's not required, just for your understanding. So this is like I was showing you in this theory now. Yes. So like this we have this hierarchies. Clear? There's no need to write this code. These two lines. ये अभी करना नेक्स्ट क्लास में करोगे लाइन प्लॉट्स
नेक्स्ट क्लास में करेंगे
ठीक है चलो we'll start from line plot from the next Saturday.
Okay, sir. Yeah.
So we'll try to finish this on Saturday anyhow, so that from Sunday we can start machine learning.
Okay.
Okay. So please come and please revise machine learning and come.
Whole descriptive and status, everything inferential.
Machine learning.
Okay, machine learning.
Yeah. At
Using
least
R, okay.
linear and logistic revise करके आना अच्छे से.
So Sunday.
Linear regression.
Sorry.
Linear regression.
हाँ जितेंद्र आपको you have to attend linear regression in the morning batch from 14th.
14.
हाँ मीन्स नेक्स्ट मंडे से उसके बाद वाला जो मंडे होगा उससे आप अटेंड कर सकते हो मशीन लर्निंग.
Okay.
ओके सो आपको
Statistics भी चाहिए क्या हिमांशु?
नहीं स्टैटिस्टिक्स अभी नहीं चाहिए बाद में मशीन लर्निंग के बाद एक क्लास लूंगा तो बता तब बोल दूंगा पढ़ने के लिए.
Sir, weekend is better for me. Actually, time नहीं मिलेगा morning में.
सॉरी
कह रहा weekend पे सही है morning में time
नहीं तो फिर ऐसा ना कि इसमें मैं मतलब ऑल दिस पीपल हैव ऑलरेडी डन मशीन लर्निंग विद आर
okay, machine learning
मतलब मशीन लर्निंग इनको